Hello, everyone, and welcome back to another Planetarium show. My name is Jessica. I'm the director of the Planetarium, and with me tonight are, well, I guess one current and one now former, though you will always be a part of the family, um, students with the Planetarium. I will let them introduce themselves, and we'll start with Eli.
Hi, I'm Eli. I'm a physics and astronomy undergraduate student at UMD.
Hi, I'm Lindsay. I am a physics graduate student at UMD, and I am graduating very soon.
Very soon. Yay. Also, sad. It's bittersweet, right? So excited, but also we're going to miss you. So everyone show Lindsay some love down in the comments because she's awesome and we are going to miss her terribly. Although I still will totally rope you into these if you want to do them.
Yep. Wish her luck. She's defending tomorrow.
Yes. All right, so tonight we have a super fun show all about kind of the science in Star Wars, taking a look at what's real science, what's science fiction, and for those of you that have been to the planetarium at least a couple of years ago, this may be a little familiar. This is a show that we've kind of been revamping and reworking to be a little bit more current, especially since we've had new movies come out. And so this is going to be a new full dome show once we are back in person. And so you're going to get a little taste of what that show is like here tonight. And Eli is going to be leading us through that. So as always, if you have any questions throughout the show tonight, feel free to leave them down in the comments. I'm going to keep an eye on those and we'll let Eli know if questions come up. Otherwise, Eli, it's all yours.
Sweet. Okay, so as usual, I'm going to need a moment to.
And I remembered to let you share.
Awesome.
Year and a half in, and I'm finally getting it.
There we go. Okay. How does that look?
That looks good.
Okay, cool. All right, so welcome to Star Wars Fact or Fiction. This show, like Jessica said, kind of started as a show that was already in the planetarium when I got there 3 years ago. We decided that it needed a little bit of polishing up. And so, especially last year when we were all kind of stuck inside and scared and alone and didn't know what to do, I channeled some of that energy into creating the show, which involved a lot of video editing and stuff like that. But it was really fun, and I'm really excited for it to actually be on the big screen in the planetarium because it's going to be even cooler than what you see now. So I'm very excited. But here's our kind of little preview version. So what we're going to do is we're going to look at some phenomena or events or happenings in Star Wars and talk about the scientific legitimacy of them and kind of how it relates to the science that we see in the real world. And the first thing we're going to talk about is binary systems. So Tatooine is a planet that orbits a binary star, which is two stars that orbit each other in space. This is what is seen in the epic double sunset scene on Tatooine, and I can like hear it in my head now. If you've seen this Star Wars movie, you know that the epic like John Williams orchestra is like rising as he walks out to the spot, the kind of sandy winds blowing through his hair. It's probably one of the coolest scenes in the series. Probably the coolest thing about it to me is that this fantastic double star that we're seeing in the sky, this double sunset, is actually a reality for a lot of planets in the universe. These binary stars exist everywhere, and up to 85% of star systems are believed to be at least binary, while some can even become ternary or quaternary, which would be 3 stars or 4 stars. It's kind of cool to know that there are planets where if there was a Luke Skywalker walking on the surface, they would see this double sunset. So it's kind of wicked. The next thing we'll talk about is habitable zones. This is also a really cool topic. So the habitable zone around stars is the range of orbits, like how far or how close from the sun or the star the planet can be, so that it would have the necessary conditions to support Earth life, such as liquid water and a reasonable atmosphere. This assumes that all extraterrestrial life would share the requirements of life on Earth, which we don't know for sure. But since we don't really have a better guess when we're looking for candidates for extraterrestrial life, we look for conditions similar to that of life on Earth because we don't know of other forms of life that would require different things. the hotter a star gets, the further away this habitable zone is from the star. So we see this vaguely in Star Wars as different worlds exhibit qualities we would see in planets at different locations in the habitable zone. So this is actually a map of the solar system, or it's like a map of the solar system, but we can liken the planets to Star Wars planets based on their proximity from the star. So really close to the star, but kind of right on the edge between the too hot zone and the just right zone, or the Goldilocks zone, is Tatooine. So we see in the movies that Tatooine is very desert-like, pretty barren, very arid, but it does have moisture to support life. That's actually what Luke's aunt and uncle's farm is. It's a moisture farm. And they get the moisture from underground to support life. That's they also live underground. This is just kind of an aside. They live underground because since there's not a lot of moisture in the atmosphere, and their atmosphere is presumably not super thick, a lot of radiation makes it through to the surface. So they live underground so that radiation gets stopped by the ground before it hits them. Just kind of a little aside. But we can also liken what would be Earth on this diagram to Endor. So when we see Endor, or perhaps another comparison would be Yavin 4, which is the moon that the Rebel base is on. When we look at Endor, we see like lush forests, almost exactly Earth-like, almost as if it was filmed on Earth. And that's very much like Earth itself. So they sit in this kind of perfect Goldilocks zone right there. Liquid water, green, stuff like that. Perfect for supporting life. Then on the border between the Goldilocks zone and the too cold zone, we have Hoth. So Hoth does have water, presumably. It has ice, which you could melt into water pretty easily. And we can tell that it's very cold based on the clothing that they wear and the overall climate and the snow and the mountains that we see. But there is life there. So it is suitable for life, but kind of on that outer edge of almost too cold. Next, we'll talk about the real-life Death Star. This is probably my favorite thing to talk about. So actually, the next thing is probably my favorite thing to talk about. But Saturn's innermost moon, Mimas, looks like the Death Star from a distance. Mimas is on the left on this image. Discovered in 1789 by astronomer and physicist William Herschel, this moon has always been likened to the Death Star since its discovery. Its discovery, however, was like the discovery of this crater, rather, the feature that makes it look like the Death Star. That crater and just kind of the overall appearance of the moon was really discovered in 1980. And I don't know if we have any Star Wars buffs, but A New Hope came out in 1977. So it's kind of weird that we have the image on the right in a movie in 1977, and then this moon discovered to look like this in 1980. The coolest thing is the crater, which is also called Herschel, is really hot. It's much closer to the center of the moon, so there's a lot of that internal heat radiating through that crater. And when you look at it in infrared, it looks like it's glowing, almost like a super laser, which is kind of cool. So the next thing, this is really cool. So we're going to talk about blaster weapons. So blaster weapons in Star Wars are commonly mistaken as lasers. But blasters actually fire, and this is from Wikipedia, which is the Star Wars Wikipedia. Blasters fire bolts of intense plasma energy converted from energy-rich gas. Well, that may sound like the work of science fiction. That's actually totally legit and has already been done. Plasma is this fourth state of matter, aside from gas, solid, and liquid, in which charged particles like electrons detach from atoms and flow freely amongst the atoms. The bolts we see here would be what's called plasmoids, which are globs of plasma held in a distinct shape by electric or magnetic fields. These fields can be generated as the bolt propagates through space by shaping the bolt in a particular way called a spheromact, which is a configuration of plasma that generates a magnetic field as the plasma moves. So it's kind of this ever-propagating magnetic field that follows the plasmoid. The spheromacts only hold their shape for tens to hundreds of microseconds, which, if it was traveling at a very fast speed, would be plenty of time for the bolt to travel to its target. And the other interesting thing, and the other realistic thing, plasma burns super hot, so they would definitely be able to do some damage to whatever they collided with. I'm talking like surface of the sun hot, like super damaging hot. While the typical Star Wars blaster may be out of reach with current technology, the ideas behind it are actually entirely possible, and it would not be impossible for there to be some type of plasma weaponry in the future. Not that there should be, because I don't think we need to develop any more dangerous weapons than we already have. But that's kind of the point of the show. It's possible. Now, okay, this is another thing that's kind of cool to talk about. So Star Wars, in Star Wars, we see very few differences between the flight on a planet and flight in space. So if you imagine like the Millennium Falcon flying in space and it flying in the atmosphere of a planet, they're almost identical. When in reality, they would be completely different experiences. On a planet with an atmosphere, your craft is subject to many forces imparted by the air the craft is moving through. Namely, one of these is drag. In order to turn, an aircraft must execute what's called a banked turn, where the plane is slightly tilted to one side, and that causes the lift force to push it in the direction that you want to turn. So if an airplane banks right, it's going to start turning right because it's being pushed to the right by the lift force. So also you have your drag, which slows you down, and you have weight from the planet pulling you down towards the planet as well. In space, however, you don't have these. The only force you would have in space is, unless you were in the vicinity of something very massive, would be the thrust force, which is generated by the ship's thrusters. So this is kind of a messy image. I apologize for that, but it'll make sense. So in space, without the presence of an atmosphere or a planet supplying lift and gravity, we'd have to create our own forces to move the ship with thrusters. For example, if we wanted our Millennium Falcon to move in the direction of the green arrow that you're seeing on screen, we'd need to combine forces in both of the red directions, which means we would need to fire thrusters in both of the yellow directions. But the problem is the Millennium Falcon only has one rocket, and that's on the back of the ship. That means that the only force represented, provided to the Millennium Falcon is the red arrow pointing to the right on screen right now, which means that it can only move forward, which is obviously different from what we see in the movies. In order to have a full range of movement like we see the Millennium Falcon and all ships having, we need to have rockets at the rear, the front, the bottom, the top, the left, and the right of the ship to provide forces that could be combined to move the ship in all directions. And that doesn't even account for like banking, which would take many, many more thrusters. But anyway, moral of the story, we see spaceflight that is highly oversimplified in Star Wars. And if we wanted to have omnidirectional movement like we see, we need to have thrusters pointing in all directions. The other thing that always grabbed my attention about Star Wars spaceflight is that all the ships are oriented in the same direction. So if you look at this planet, granted, we are orbiting Coruscant right here, but it's the same even when we're not orbiting the planet. All of the spaceships are like oriented in the same direction, like up and down is the same to all the spaceships, which really doesn't make any sense. It doesn't break any laws of physics or anything like that, but it's interesting that when in space where there's no up or down or proper orientation, all of the ships are always oriented in that same direction. In reality, the ships would likely be oriented in completely different directions, as the planet they launched from are all at different angles, and they change directions as they bob and weave through asteroid fields, stuff like that. So just kind of another little interesting point. Speaking of asteroid fields, let's discuss the issues with Star Wars's asteroid field scenes. So in Star Wars, we see spaceships bobbing and weaving through extremely dense, almost impossible to traverse gauntlets of enormous boulders, sometimes populated by space worms. In reality, flying through an asteroid field, particularly the solar system's asteroid belt, would be almost no different than flying through empty space. A probe flying through our asteroid belt has less than a 1 in a billion chance of colliding with something, and multiple have traversed that region without imaging or seeing a single asteroid in their vicinity. So the asteroid belts that we see in Star Wars would be much more likened to a planet's ring system, maybe, or something that is much more dense. Asteroid fields themselves are actually pretty thin, and we wouldn't see the kind of trials that they go through in Star Wars in real space, or at least in our solar system. Speaking of ring systems too, we're going to switch to this scene. So another problem with space in Star Wars, specifically space fights, is the fact that we see seismic waves and sound propagate through space. If you've seen the movie, oh shoot, what's that called? Attack of the Clones, right? Lindsay, back me up. Attack of the Clones, or is it Clone Wars? No, Clone Wars is the show.
Yeah, Attack of the Clones.
That's right. Thank you. I'm ashamed. But so if you've seen Attack of the Clones, you know this is the scene where Jango and Boba Fett are chasing Obi-Wan as they head towards this planet through its ring system, and you can hear the sound. It's like this really like seismic. I'm not going to try to imitate it because I'd make myself look like a fool, but it's a very resonant sound. It's very notable. Unfortunately, this would not happen in space because there's no medium for the sound to travel through. Sound is the vibration of air molecules. That's really all it is. And we hear it because the air also wobbles our eardrums, which our brain pieces together as sound. Seismic waves, such as the wave created by the Slave Ones, which is Jango and Boba Fett's ship, seismic charge, which you're seeing in the GIF here, are waves that propagate through the Earth's crust or any material as the result of an earthquake or some collision or something like that. In space, there's no medium for these vibrations to happen, and thus neither of these effects would be possible. So this charge would actually do nothing unless there was a really, really thick atmosphere, which there's not out here. Another cool thing to talk about is space travel. So traveling through space would be no easy task either. We'll talk about hyperspeed in the next slide, but for now, let's get a really good idea for how large the distances through space really are. So the fastest speed reached by a man-made object was 153,454 miles per hour, and this was achieved by the Parker Solar Probe in 2018. Even traveling at this speed, it would still take 40 days to get from the Earth to Mars, which is 2 planets in the same system. If we wanted to go from one planet to another at the other side of the galaxy, like the journey from Tatooine to Ilum, which is respectively the home world of Anakin and Luke Skywalker, and the planet on which Jedi younglings complete their trials and harvest their kyber crystals to power their lightsabers. I'm such a nerd. This would take 462 billion years, or about 33 times the age of the universe, to traverse in the fastest man-made object. And those are just 2 planets in the same galaxy in Star Wars. So it seems a little hard to achieve right now, but thankfully Star Wars came up with something to accomplish this. In order for ships to travel great distances in short amounts of time, they enter a dimension called hyperspace. Hyperspace acts as a shortcut between points A and B, and in order to get there, ships must reach the speed of light. While hyperspace is a nice way to make some lore behind the mystery of going light speed kind of more like accessible, the bigger problem is getting to light speed itself. As an object's speed increases, it takes more and more energy to accelerate to greater speeds. And once the speed of the object starts getting to those of like tens of percents the speed of light, the energy required to accelerate that object becomes increasingly large, and it eventually becomes impossible. It effectively, as you get closer, it's impossible. Additionally, rather than launch from low speeds to light speed very quickly, as we see in Star Wars, you'd have to gradually increase your speed, as the inertia would kill you if you went fast enough. That's why there are inertial dampeners in Star Trek, but Star Wars doesn't count for that. So you'd have to gradually increase your speed and use an infinite amount of energy to reach light speed, which is impossible. So that science is invalid for now, hopefully only for now. One thing Star Wars did get right, despite the widespread belief that it was misinformed error, however, was the famous Han Solo line, "The Millennium Falcon made the Kessel Run in 12 parsecs." At first, it sounds like Han said it made this drive in this distance, which would be like saying, I drove from Minneapolis to Los Angeles in 20 miles, which doesn't make any sense. A parsec is a unit of distance equal to just over 3 light years. So when he says the Millennium Falcon made the Kessel Run in 12 parsecs, it sounds like he said the Millennium Falcon drove 50 miles in 10 miles or something like that. It doesn't really make sense right off the bat. But what Han was actually saying is that since the Millennium Falcon is so fast, he was able to take a shortcut through a dangerous region of space to make the trip shorter. The Kessel Run is a maze-like region of space surrounding the planet Kessel, which is kind of like a mining and I believe like a spice harvesting planet, although not the kind of spice that's in Dune, actually just like seasoning spices. It is littered with chunks of matter, ice, rock, stuff like that. Traditionally, one would have to travel through the maze to avoid these obstacles, as well as avoid the maw, which is a cluster of black holes embedded in the maze of materials. So on this picture on screen, the blue arrow is the traditional Kessel Run. The black oval is the maw, and the orange arrow is the path that the Millennium Falcon took. So rather than take this blue arrow to avoid all the dangers, and especially the maw, which is kind of a region of black holes, Han just flew right through the maw because his ship could go fast enough to bob and weave through the black holes without getting sucked up in their gravity. So that's actually totally legit statement on Han's part. You just kind of need to be into the lore behind it to understand it. Finally, we arrive at the lightsaber. While lightsabers are probably the coolest thing I've ever seen, they don't really quite work out the way we would hope they would. Lightsabers could be constructed in the same way the blaster bolts were made, with the plasma contained by a self-generated magnetic field, like we said with the Spheromax, or with an actual laser generated in the hilt, but the energy required to consistently heat the plasma or power the laser would be far too much to be able to hold in your hand. Also, there would be no way to stop the plasma at the end of the blade, and you would be left with an infinitely long blade, which is not super convenient. If it were made of light, you'd have to stop it with some type of mirror, which not only ruins your ability to stab with the saber, but will send the light back at the hilt and ruin it and burn your hand. You'd also have to cool the hilt, which would take so much energy and space, and this is turning into like a room-sized apparatus that you're supposed to hold in your hand. Not to mention the battle constraints are pretty devastating. So since the plasma is extremely light and the light is massless, the weight balance would all be in the hilt, unlike a sword where the weight balance is somewhere in the middle. And this would make swinging the blade like super awkward and very difficult. Also, due to the fact that plasma and light aren't solid, we'd get none of the cool noises made as blades clash together. They just like go right through each other. There would be no effect. So kind of underwhelming, but luckily for us, we don't have to end on a dream crushing note. We'll take a look at the closest thing we have to a lightsaber at the moment. This is the Protosaber, as constructed by popular YouTube engineers under the channel name Hacksmith. This weapon, which is a lightsaber with an attached battery pack, which is actually canon. That's true to Star Wars lore. Before they held the lightsabers in their hand, they had an attached battery pack that was on their waist. And it was called the Protosaber. The Protosaber has a tungsten blade. Tungsten is the element and with the highest melting point, so it can get very, very hot before it melts. It has a tungsten blade that heats up to 3,000 degrees Fahrenheit, which is hot enough to cut through many materials, and it's the closest thing we have to a working lightsaber right now. You can check out their video on YouTube, although I should make a warning, this is not a child-friendly channel. There is, some foul language used and stuff like that. So if you're underage or you don't want your child to see that, don't let them watch it. But check it out for yourself. It's really cool. I don't know where I saw it, but I think they came out with a new version of it that's supposed to be even closer to a lightsaber. It has some more cool features or something like that. This is not updated to that because I just saw it not too long ago, and I wasn't sure where to find it or stuff like that. I think I saw it on a Facebook ad or something, but look for that as well. So that is all I have. So I'm going to stop sharing.
That was awesome. Yay, and I'm so excited, just like you were saying, to see this in the dome. Because we can actually have the movie clips.
Yeah.
Which we can't show on stream without getting copyright.
Yep.
Plus, we want you to have a reason to come see it in the planetarium.
Mm-hmm.
So, yeah, it's gonna be a very cool show, and I know we teased it, but I don't have an opening date for you yet.
Yeah.
We're still working on getting the new system installed, and yeah, so, but, so I don't see any questions right away. There is a congratulations to Lindsay.
Thank you.
Yeah. So if anyone has questions, go ahead and throw them down in the comments. Although I think Eli did a pretty great job explaining all of the different things, and I think it's nice to see like some legit science.
Yeah.
I will admit that I have had a time period where I've like had to stop watching science fiction.
Yeah.
Because all of the wrong science just bugs me so much. And so like having some that is a little bit better. I will say things like The Martian did pretty good
Yeah.
on the science.
Martian
I know
was
there
really good.
were a couple things like the actual strength of like the winds on Mars were inaccurate.
Yeah.
But yeah,
Interstellar also got it like pretty much all right up until they
I still
took the
haven't seen it.
liberties at the end. Yeah, Interstellar got most everything right, but they took a lot of
Well,
story.
I am gonna watch it. I have to watch it.
I'm
It's
just
on our
saying
movie
that
poster.
it gets kind of fantastic towards the end, so that's not
Okay.
super scientifically accurate.
Kind of like 2001: A Space Odyssey.
Yeah, yes, exactly. Which also, if you haven't seen it,
I have not seen that one yet either.
fantastic movie. Oh my goodness, it's so good.
I'm bad. I'm so behind, and a lot of it is because I just stopped watching because I was getting so frustrated.
Space Odyssey is one of the best ones.
All right, so we just got a question. Is there a science fiction movie, novel, or series that you think is the most accurate scientifically? The Martian, that we were just talking about, does really good.
Can you even call that science fiction though? I feel like that's just like. Can you though? Like I feel like that's
consider
like,
that science
one's
fiction.
like so close. Like I feel like that one is just like a novel at that point.
But it's still, I mean, it's based in science and it's a fiction story.
Maybe that's just a testament to how real it gets.
Yeah.
Martian is super close.
I haven't read his other book yet. I have it. It is on my giant stack of to read books. I'm very excited for it. I will say Michael Crichton is another really great one. You can tell, well, he did get some things incorrect. Like, I'm not saying that he was infallible. You can tell the amount of research that he did to try and make things as close as they could get. And also keep in mind some of the books were written, like some of the stuff in Jurassic Park isn't accurate anymore, but at the time he wrote it, that was accurate based on our understandings.
But as it happens, like at least this might just be my opinion, but like science fiction that's super awesome and like enjoyable is usually further from the truth. Like the more fantastic it gets, the further it gets.
But you can have fantastic and still have accurate physics.
Yeah.
A good movie for kids that actually is pretty good at accurate flying through space at the very least, WALL-E.
Yes.
I actually show clips of WALL-E when I'm teaching Newton's laws in my physics classes.
Yeah, they do a great job with that.
And the whole thing where they lose bone density and things like that, that really happens to astronauts in the ISS.
Yeah. And like I said, Interstellar is really good too. They get like all the flying mechanics and stuff like that perfect. They get like time dilation super well. That's super cool. And like pressure on planets and stuff like that. They get it really good. And the black hole apparently is like, like they used like kind of bleeding edge computer simulation to see what it would look like.
And it actually matches. Yeah.
Yeah, and then like 3 years later, when they actually took a picture of a black hole, it looked the same. So they get it pretty good.
Yeah. So we have a follow-up question to that. So as the level of knowledge and discovery changes, what sorts of themes and ideas do you think might emerge in future literature and film?
Whoa.
Yeah, it's kind of a deep question, right?
Well, I think there's still a lot that we are a long way away from, like speed, the speed of light speed travel. We're nowhere near getting anything that close, and the closest star to us is 4.2 light years away. So even at light speed, it would take us 4.2 light years, 4.2 years to get there going at light speed. So there's still a lot that we can't do as a species. And so I think, you know, having things like that in the science fiction where they're able to travel, you know.
But I can also see, as we're finding more exoplanets and even more Earth-like planets and getting closer and closer to hopefully finding evidence of other life, I see that's really becoming a huge theme. I mean, aliens have been a big theme in sci-fi, but
they find some.
Yeah, and it would be more than just like Martians, which is what kind of started it off.
Right.
So I can see that.
I think another thing, it's not like super astronomy, but it's kind of physics and computer science too. Like, I think as computing power gets a lot stronger, I think the ideas of like as we as a species become more capable of running like large scale simulations and stuff like that, like I think that trope will probably get a lot bigger as we get closer to having more computing power and like having the computer power to do stuff like that. I actually just watched a video on it the other day. If you don't watch the channel Kurzgesagt on YouTube,
you so should.
Really good.
Yeah, first of all, it's fantastic. Like all of their stuff is super good. I'm not going to pretend to know how to spell it, so I'm going to look it up. But Kurzgesagt, so I don't know, I can't really type it out, Jessica, if you want to comment or something, but it's Kurzgesagt. They have a fantastic video on like simulation stuff. And like, I'm not trying to be like a weird, like, oh, we live in a simulation. Like, I'm not trying to do that. But like, it's just kind of interesting that like, as we get, you know, more, that's my really long-winded answer.
Yeah. And I mean, to be a little, the closer we are getting to devastating our climate,
for sure.
Is going to become another major theme.
Yeah, going to planets isn't going to be an achievement anymore. It's going to be a necessity. We're going to need somewhere else to put in.
So I did just put a link to that YouTube channel in the comments.
Check it out.
It's amazing.
And they do videos on all types of stuff. They do a lot of astronomy. They do a lot of like
science, technology,
science, and like evolutionary history, stuff like that. It's super cool.
Yeah, good for all ages.
Yes.
Yeah, it's kind of like a crash course, but like a little more widespread, like type thing. Like they do super short crash course episodes for all ages. It's really cool.
Yeah, it's great. And I have met one of the copyright editors for the channel. Yeah. It was so cool.
Yeah.
Well, virtually met, I guess, but still, that counts in time of COVID as meeting, right? This has actually been fun. I kind of want to do a full show on just like talking about science fiction in general.
Yeah. Also, Dune. Dune is fantastic. Not super realistic, but super good. Dune is awesome.
I am waiting because I read the book years ago and don't remember much. I'm waiting so that I can watch the movie because that's another big thing. I hate when movies are inaccurate to books. My mom's still in the channel, or in the stream, she can attest to how picky I can be. So like, I want to watch because the movie looks amazing.
Yeah, it looks super good. Apparently there's also like a whole second one that's already written, if the first one does well.
Yeah, I have heard that after the first book though, they kind of fall off.
Also, another really good one that I feel like gets ignored because I don't know why it gets ignored, honestly. Ender's Game. Ender's Game is fantastic. Super good.
So good.
The movie, not so much, but...
Never even watched it. Didn't try.
Don't bother.
Because I knew.
My favorite science fiction novel is Left Hand of Darkness by Ursula Le Guin.
I don't know that one.
And, I like it because this space traveler is on this planet, and she has between each chapter like a folk tale or like history from that planet, and it's really cool.
Oh, I like that. Okay.
I'm just looking through my background. Speaking of 2001. Turn this on. Also, another really good one, not super astronomy related. Do Androids Dream of Electric Sheep? It's a really good book. It's what Blade Runner is based on. And If you know me,
which I finally watched.
Yeah, it's so good. It's so good. Watch the movies.
All right. I think we could keep going off on this tangent for a while. But let's.
I will die on that mountain. That's no problem.
we have talked about that for, God, what did we talk, like 45 minutes just on that?
Yeah, collective hours probably.
You're kind of getting a sneak peek into what some of our staff meetings are like. It's like,
especially when we're working in the planetarium, there are no windows, and so we don't know if it has like gotten dark outside and how many hours have passed.
No, yeah, and so like we'll work, and then we get on a tangent and start talking about sci-fi movies.
Yeah.
So this is a little sneak peek in our dynamic behind the scenes, which I still think, like, if you're interested in maybe having a more low-key, chill show like this with us just kind of talking about our favorite sci-fi, let us know in the comments, because we are always looking for new stuff to be doing on stream, because after, a year and a half, we've done quite a lot, and are always looking for new ideas to keep you guys entertained and learning. That's what we do. All right, before I wrap up, let me show you what's coming up for the rest of the week. On Saturday, it is our next episode in our exploration series. We're going to be taking a close look at the life and death of stars. A lot to talk about, but we're going to do as much as we can in about half an hour. And then next week is somehow September already. I still feel like we just started August, so I don't understand. But that means we'll be doing our beginning of the month shows. So we'll have What's Up September edition on Wednesday and September Constellation Storytime on next Saturday. Guys, it's almost September. Like, how?
Yep, classes start next week.
Not ready.
Me neither. This semester I have.
All right. Well, thank you everyone so much for joining us. I don't want to say it, but thank you, Lindsay, for everything. Again, I'm gonna try and rope her into more shows so that she's not gone after this. But thanks for joining us. Check out us, all the other stuff that we do on other nights. We also have backlogs of our past live streams in the video section of our YouTube channel. We got private shows that we're doing right now. Hopefully we'll have some news in the next couple weeks about public shows. And yeah, we will see you again next time. So bye everyone.